Okay, so for this video lecture, we're going to discuss about glasswares, plasticwares, and measuring vessels. So the learning objectives for this topic is that at the end of the lesson, you're going to differentiate the importance of glasswares and plasticwares. Second is to compare and contrast the different categories and or types of glasswares used in clinical laboratory. Actually, not only we're going to discuss the types of glasswares, we're also going to discuss the types of plasticwares. No? And then third, enumerate the measuring vessels used in the clinical chemistry laboratory. And fourth is to classify pipettes based on specific criteria. So before we proceed with the lesson proper for this topic, let's have first the references. So for the references of this topic, we have three. First is for Bishop. So for Bishop, you may use the 6th or 7th edition. What I placed here was the 7th edition. So for the 7th edition, you can refer to chapter 1, pages 11 to 17. Another reference for this topic is Tietz. So Tietz 7th edition. So you may refer to chapter 8 of this reference from pages 114 to 116. And the third reference would be the Henry's na libro. Okay? You may refer to chapter 4, pages 60 to 61. Okay? So let us now formally begin with the topic on plasticwares and glasswares. Okay? So to formally start, let us first try to answer the question, why do we use plasticwares or glasswares in the laboratory? Actually, now there are three main reasons why we use glasswares or plasticwares in the laboratory. First, remember that when we use reagents or chemicals in the laboratory, not all of those reagents, or rather not the entire available reagent, is used instantly. Okay? Diba? There are times na, for example, yung supply natin ng chemical is 1 liter, ang gagamitin na natin for a specific test is, for example, 10 milliliters. So, saan mapupunta yung sobra? So, ilalagay natin siya sa isang container, and that container could be made of glass or plastic. So, in that scenario, the reason why we use glasswares or plasticwares is for storage. Second, so for the second reason, I think naka-experience na kayo while doing lab works na when we are doing measurements in the laboratory, we also use glasswares or plasticwares, but usually glasswares. Like for example, when we measure liquids, we use graduated cylinder, beaker. We have also your volumetric or Erlenmeyer flask, and even for plastic, an example would be the pasture pipette. Okay, so from that, we can say that your glasswares or plasticwares could be used for measurement. And the third main reason why we use glasswares or plasticwares in the laboratory is for containment. Diba? When we are performing actual experiments, we need something where we can place temporarily our chemicals or reagents like test tubes, okay, like our wash bottles. So this means, class, that your glasswares or plasticwares could be also used for containment. Okay, so those are the three main reasons why we use glasswares or plasticwares in the laboratory: for storage, for measurement, or for containment. Now let us focus first discussing about the advantages and disadvantages of using plasticwares and glasswares before we proceed with the discussion on the different types of glasswares or plasticwares. So for your plasticwares, the advantages would be it is cheaper compared to your glasswares. It is more durable. When we say durable, it means that your plasticwares is more capable of withstanding pressure. It is capable of withstanding yung tinatawag nating wear and tear. And it is capable, no? It is more capable, rather, of withstanding damage, no? So that's what we mean when we say that plasticwares are more durable, okay? Also, your plasticwares, they are preferred for some analysis, especially if we are performing heavy metal testing. Okay? Kasi po, pag nagpe-perform tayo or when we want to measure the heavy metal level, for example, in the blood of a patient, no, we need to make sure na hindi tayo gagamit ng glasswares. If gagamit po ng glasswares, dapat po it is totally free of contamination. And how can we ensure that it is totally free of contamination? Of course, dapat po yung glasswares natin, it should be carefully and thoroughly cleaned. If the question now would be, Sir, paano po natin lilinisan ng maayos yung glasswares na para pwede silang gamitin for heavy metal testing? Now, that will be answered later on. Okay? Basta yung point lang po ngayon, no, if gagamit ka man ng glass, kasi sinabi dito, no, bawal gumamit ng glass for heavy metal testing. If gagamit ka man ng glass, make sure that it is carefully and thoroughly cleaned. Okay? So kung titingnan mo, tedious or hassle pong gumamit ng glass, no, kapag gusto mo mag-perform ng heavy metal testing. Okay? So, another reason kung bakit hindi din pwede yung glass gamitin is because glass, no, some glass no, can absorb metal ions. Okay? So, they can absorb metal ions. That's why, no, mas preferable na gamitin yung plastic. Or kung wala mang plastic, disposable na lang na glass. Okay? So, yun po yung mga reasons. For disadvantages, so the disadvantages of using plasticware is madali pong mag-evaporate yung mga dyes, stains, or proteins. Okay? Na nasa, na nilagay mo sa loob ng plasticware. Bakit po siya nag-evaporate? Even water actually can evaporate. No, kahit tinakpan mo na yung plasticware, no, kahit nakatakip na yung plasticware, mapapansin mo kapag matagal na siya nakastand dyan sa isang lugar, no, nababawasan yung kanyang volume. So what's the reason behind that? The reason behind that is actually because of this what we call polymer permeability. Okay, it's what we call polymer permeability. So, sir, ano po yung tinatawag nating polymer permeability? Actually, that what we call polymer permeability, the concept of that one is actually similar to the concept of the cell membrane. Okay? Diba? When we talk about the cell membrane, it actually, no, allows specific substances to diffuse or to pass through its membrane. Same goes with your plastics, okay? So there are substances that could easily diffuse in plastic, okay? Kaya po, for example, may wash bottle ka, laman nun tubig lang, for example, distilled water, tapos hinayaan mo siya mag-stand for a long time, mapapansin mo, no, mababawasan yung kanyang volume. Okay? And again, the reason for that one is the what we call polymer permeability. Okay? So those are the advantages and disadvantages of using plasticware. How about for glasswares? For glasswares, I think the disadvantage for this one is very obvious. Okay? So, pag sinabi pa lang glass, no, madali siyang mabiak, ganon. Mas expensive siya. Okay? So, kung yun yung mga disadvantages ng glasswares, so ano naman po yung mga advantages? Yung advantages po ng glassware, pwede mo pong painitin yung ating glass. Okay? Kasi kung yung plastic ang papainitin mo, for sure, no, malaki yung possibility na matutunaw siya. Okay? So, one advantage of glassware is you can use it for heating. But I hope, no, napansin niyo sa inyong lower year levels, especially doon sa lower na chemistry subjects nyo, napansin niyo po, di ba, na hindi lahat ng glasswares ginagamit sa heating. For example, when we have your graduated cylinder, di ba, kailan nyo ba siya ginamit na nilagay niyo yung isang chemical doon at pinainit nyo? Or graduated cylinder tapos ginamitan yun ng Bunsen burner. O di kaya beaker, ginagamit naman siya for heating. O di kaya yung tinatawag nating volumetric flask. Okay? So, meron po tayong mga glasswares na hindi po pwedeng gamitin for heating. Okay? But again, of course, there are some na pwede gamitin for heating, so that will now make the glasswares have an advantage over the plasticwares. And also, no, for glasswares, it allows longer storage of some chemicals. Now, additional information for glasswares, make sure po na when you are using glasswares in the laboratory, make sure that it follows or it is classified in either Class A or Class B. Ano po itong sinasabi ko na Class A or Class B? So pag sinabi po natin Class A or Class B, meron po yan siya because of this what we call NIST or the National Institute of Standards and Technology. Okay. So again, your NIST. So yung NIST po, that stands for National Institute of Standards and Technology. Okay? So, anong kaibahan ng Class A and Class B? Pag sinabi po natin Class A yung glassware, ibig sabihin po, sila yung mga glasswares na bagay talaga for laboratory because they possess or they exhibit the highest level of accuracy. Okay, that's for the Class A na mga glasswares. Yung Class B naman po, yun yung ginagamit lang for general purpose work. Okay, so they are calibrated to a lower level of accuracy compared to your Class A. So, when talking about glasswares, no, mas better po na ang gagamitin ay Class A. Okay, so yun po siya. Now, let's proceed with the cleaning of plastic or glassware. So, ito yung sinasabi ko kanina. So, those plastics or glass na merong direct contact with biohazardous material should be disposed properly. Okay? So, to dispose them properly, we follow this what we call decontamination protocol. So, ano po itong decontamination protocol? First po, ang gagawin natin, yung na-expose na plastic or glass, you're going to immediately rinse that one. After immediately rinsing that one, you're going to wash it with either powder or liquid detergent. And remember po, it is emphasized in your bishop, okay, that pre-soaking is recommended when immediate cleaning is impractical. Okay, so yun po siya. Now, if you want to know more about the decontamination protocol for your plastics and glass, you can read furthermore in the chapter 1 of Bishop. Okay, also, before we proceed to the next slide, I would also like to inform you or to tell you that when we are performing decontamination, you need to make sure that the detergents that you're using and the temperature levels that you're using are compatible on the material that you are cleaning, and it is based on the manufacturer's recommendations. Okay? So now let us proceed into discussing the different types, the major types of plastics or resins used in the clinical chemistry laboratory. Now, if we're going to base it on on the book Henry, so there are actually 5. So we have our polystyrene, polyethylene, polypropylene, Teflon, and your polycarbonate. But if you're going to look at Bishop, yung reference na Bishop, actually may dinagdag pa siya dito. No? So aside from these 5, dinagdag po ni Bishop yung, type natin, yung Tygon. Okay, Tygon. And after Tygon, dinagdag din niya yung tinatawag nating polyvinyl chloride. Polyvinyl chloride. Okay? So, yan po lahat ang kay Bishop. But what we're going to elaborate more in this topic are the first 5. Okay? Si polystyrene, polyethylene, polypropylene, Teflon, and polycarbonate. Now, before I elaborate this one, this 5, I would like to introduce to you this what we call resin identification code. Okay, so what is this code? This is actually a number coding. Okay, so the number here is actually or can actually be seen now at the bottom of most plastic bottles and food containers, no, and the number describes, no, what kind of plastic resin the product is made out of. Okay, so ito siya, additional information lang po. Kapag yung nakita nyo, for example, uminom kayo ng tubig and then tinignan nyo yung kanyang code, no, yung kanyang number. So kung napansin nyo po doon, ang nakasulat ay numbers 1 o di kaya number 2, 4, or 5, ibig sabihin po, safe po yan sila na gamitin ng mga plastic. Pero kung nakasulat po ng mga numbers ay number 3 o di kaya number 6 o di kaya number 7, mga toxic po yan sila na plastic. So next time, no, bantay-bantay po tayo sa kung ano yung mga na-encounter natin ng mga plastics. Okay? Kasi po, again, yung safety ng plastic, no, makikita nyo yan or ma-assess nyo yan through the numbers. No? And those numbers, okay, belong to this what we call resin identification code. Okay? Also, additional information po, did you know, no, na 95% of all plastic products were positive for estrogenic activity. No? What do we mean when we say estrogenic activity? No? Ano po ibig sabihin niyan or ano implication nito? Implication po nito, no? Your plastics, they contain chemicals that can potentially disrupt your hormones, no? And they can cause adverse health effects. No? So I believe, no, from this statement, I believe that dili jud friendly si plastic, no? Hindi siya friendly to the environment, hindi din siya ganun ka friendly sa tao. Okay? So, I guess ganun yung property ng plastic is because no, synthetic kasi siya. Hindi siya natural. Okay? So now let us proceed with the different types of resins or plastics. Let's begin with polystyrene or polystyrene. Okay? So the characteristics of this type of plastic is that it is rigid, it is clear, and remember po, it should not be autoclaved. I hope you're still familiar with an autoclave. Kasi supposedly dapat ito siya, na-introduce na ito siya beginning MLS1. Okay? Specifically dun sa microbiology na topic. Okay? So your polystyrene po should not be autoclaved. Disadvantage po ng type na ito, it is not resistant to most hydrocarbons, ketones, and alcohol. And your polystyrene tubes, no, they crack and splinter when crushed. Okay? So si polystyrene po, pwede nyo siya makita. It's actually a component of capped graduated tubes and test tubes like this one. Okay? Also, no, additional information again, okay? Your polystyrene can also be seen in your styrofoam. Kaya siya tinawag na styro. Okay? Because it contains your polystyrene. Okay? The second type would be your polypropylene. So this one, its characteristics, it is flexible, or rather it can be flexible or rigid. It is chemical resistant, and this time around it can be autoclave. Now, I want you to remember this statement here because it's actually one of the common questions that appears in the board exam. So the question usually states na what is the type of plastic seen in the, or what is the most common type of plastic seen in the pipette tips? So the answer for that one would be polypropylene. Okay, so polypropylene again is the primary constituent of pipette tips. So what are the uses of polypropylene aside from being one of the components of your pipette tips? No, another use for your polypropylene is that it can be used for cryogenic procedures. I think you're familiar with the term cryogenic because you have already encountered that term in histopathology. right? Okay, so your polypropylene can also be used in cryogenic procedures. Why? Because this type of plastic is specially formulated to withstand temperature, no? Down to negative 190 degrees Celsius. Okay? Now, another thing, no? Kung saan pwede po natin makita si polypropylene ay ito siya. Okay? So I know familiar sa inyo ito. Okay? Ang iba dito makikita sa National Bookstore. Ito siya casing ng CDs. Okay? Ito kay Baunan. So, no, nakikita po si polypropylene dyan. Okay? The third type of resin is your polyethylene. This one now, it can be used as part of making your test tubes, the bottles, the wash bottles, for example, graduated tubes, and even the stoppers. However, disadvantage of using polyethylene is that it binds to proteins, dyes, stains, and picric acid. That is why it is stated here that it is not suitable, no, when using picric acid, stains, dyes, and proteins, because your polyethylene binds or absorbs them. Okay? Okay? And then if you're going to use this one in the laboratory, it could cause an alteration in the result. So, possibly, no, magiging or magkakaroon na ng error yung results nyo. Okay? So, saan po ba pwede rin makita si polyethylene? Ito siya. Yung mga plastic balls, yung ating, ang tawag nito, ito yung ginagamit pang cover ng mga take home, no, pag merong house party. Okay? So yan, no? Makikita si polyethylene dyan. But again ha, I'm not saying na purely polyethylene or yung kanina na examples, purely polystyrene yun sila. Okay? So ngayon, I want you to remember na hindi ito sila purely plastic lang. Okay? So may mga dinagdag pa dyan na other chemicals. Okay? Fourth type of resin, we have your polycarbonate. Okay? So your polycarbonate po, its characteristic, it is a very strong plastic. But it is not suitable for strong acids, bases, and oxidizing agents. No? Kaya po sinulat dito, not chemically resistant. Okay? Because again, it's not suitable for strong acids, bases, and oxidizing agents. And then, this one is autoclavable. Okay, so pwede siya ilagay sa autoclave but with limitations. And for the limitations, you need to refer again to the manufacturer's instructions. Okay? Okay, so you can use this type of plastic now if you're dealing with negative 100 degrees Celsius up to 160 degrees Celsius. And inside the laboratory, you can see it in the tubes for centrifugation, even in graduated cylinders, especially if yung graduated cylinder na ginagamit is may plastic, and your flasks. Okay? Okay, so before I proceed, wala akong nasabi kanina, for polyethylene, the polyethylene po in terms of autoclaving, bawal po siya i-autoclave. Okay? So bawal i-autoclave. Si polyethylene. Okay, same kay polypropylene, di ba? Si polypropylene, bawal din siya anong tawag nito? Sorry, not polypropylene, but polystyrene. Okay? So, di ba, si polyethylene at saka si polystyrene, bawal silang i-autoclave. Si polypropylene, pwede siya i-autoclave. Si polycarbonate, autoclavable but with limitations. Okay? So, I'd just like to clarify that one. Then for polycarbonate, so aside from seeing polycarbonate in these things, you can also actually see polycarbonate here. Ito siya. Dito. Okay? Then the fifth type of resin is your Teflon. So this one, its characteristic, it is almost chemically inert. When we say inert, when we say chemically inert, it means that the substance is not chemically reactive. Okay, so that's your Teflon, no? Not chemically reactive. Almost not chemically reactive. Okay, so it is chemical resistant. In other words, no, it is resistant to your acids, your bases, alcohol, and hydrocarbons. It is suitable if you're working in temperatures negative 270 degrees Celsius to 255 degrees Celsius. And it can be seen in your steering rods, in tubings, cryogenic vials, and bottle cap liners. Okay? And I know, very familiar sa inyo si Teflon. Okay? So nakikita din siya sa pans. Diba? As a component of yung mga panluto natin. Okay? So that's for the major types of resins or plastics. Now we will proceed with the major types of or categories of glass. So there are actually 7, no? But what I'm going to elaborate now are the first 6. Okay? So let us begin with your borosilicate. So your borosilicate is the most common type of glass encountered in the laboratory. Okay? Lalo-lalo na sa clinical chemistry na laboratory. Actually, your borosilicate is named as such because of its composition. So this is the composition of your borosilicate gas. As you can see, it is made up of 80% silica. Kaya po may word na silicate sa kanyang pangalan. And then after that one, meron din siyang boron. Okay? Kaya po ang pangalan niya is borosilicate glass. Okay? So, also, I would like to tell you that the borosilicate glass is also called as the hard glass. Now, if you're going to search in the internet, it is also known as the hard glass. So, sir, meron tayong tinatawag na hard glass. Meron din po bang tinatawag na soft glass? Yes, meron din pong soft glass, but later natin siya ma-encounter. Okay? So, yun siya. So what are the characteristics of borosilicate glass? So first, it has a high degree of thermal resistance. Okay? So I guess that one is easy to understand. Also, your borosilicate glass has a low coefficient of thermal expansion. Now this one I would like to elaborate or explain. So what do we mean when we say thermal expansion first? So when we say thermal expansion, remember, that is the tendency of matter to change in shape, area, and volume in response to a change in temperature. Again, when we say thermal expansion, it is the tendency of the matter to change in shape, area, and volume in response to a change in temperature. In other words, when we say low coefficient of thermal expansion, ano po ibig sabihin nito? Ibig sabihin po nito, kahit mataas na yung temperature na expose yung ating borosilicate glass, hindi siya madaling maapektuhan in terms of shape. In other words, hindi siya madaling mag-melt. Okay? So hindi siya madaling hindi madaling maapektuhan yung kanyang shape, yung area niya, yung original na volume niya. Okay? Kasi mababa lang yung coefficient of thermal expansion niya. Mababa lang yung tendency niya to change in shape, area, and volume in response to that increase in temperature. And because of this low coefficient of thermal expansion glass, actually this is the reason why it is or it allows manufacturing of heavy walls. What do we mean when we say heavy walls here? When we say heavy walls, yung mga glass nga na makakapal na masyado, okay? Yun yung dinedescribe ko ngayon na heavy walls. Diba? Kasi may, for example, may mga bottles na napapansin nyo, makapal masyado na siya. Parang maraming layers. Maraming layers. So, yun yung nire-refer ko na heavy walls. So, because of the low coefficient of thermal expansion, it allows manufacturing of those kinds of glass already, those kinds of borosilicate glass. And as a result, okay, so those heavy walls gives more mechanical strength to the glass. Kasi nga, mas kumapal na yung glass. It gives more mechanical strength to the glass while retaining a reasonable heat resistance. Okay? Okay. Another characteristic of your borosilicate glass is that it has a low alkali content. That is why it is resistant, or it can be resistant to alkali corrosion. But remember po, we have a precaution for alkalis. Now, later, we will discuss the precautions related or pertaining to that one. Okay? And the third characteristic of your borosilicate glass is that it is free of heavy metals. Okay? It is free of heavy metals. And then, another, now you can actually use your borosilicate glass for heating. But again, we also have precautions for heating. Okay, so what are these precautions I'm always talking about? So there are actually 3 precautions that I would like to emphasize when using borosilicate glass. First precaution po, okay, storing concentrated alkali solutions will etch or destroy the calibration of the glass. In other words, yes po, it is alkali resistant. Okay, it can resist the corrosion caused by the alkali, but no, may limit lahat ng bagay, correct? Okay? So same with your borosilicate glass, no, may limit din po siya, no? Pwede nyo siyang gamitin with when you are dealing with alkali, pero hindi nyo pwedeng i-store yung alkali sa kanya. Especially if yung alkali na yon is very concentrated. Why? Because again, a very concentrated alkali solution can cause etching or it can destroy the calibration of that glass. And once you destroy the calibration of that glass, it will not be anymore capable of giving an accurate measurement of a volume when you are using and when you are going to use it in another laboratory procedure later on. Okay? So that's for the first precaution. The second precaution, heavy walled type of glass should not be heated with direct flame or hot plate. Sir, bakit hindi siya pwedeng gamitin kapag nagpapainit tayo ng liquid? For example, na sinabi mo kanina na yung borosilicate gas, no? Malaki yung kanyang mechanical strength, and then na-retain niya yung kanyang heat resistance. Yes, sinabi doon na-retain yung kanyang heat resistance. But again, makapal na po yung wall ng glass. So, hindi madali para sa kanya to adjust to the changes in temperature later on. Okay? So, for example, makapal yung glass. No? So, nagpainit ka. So, mainit na yung entire heavy wall ng glass. Okay? And then, bigla mong tinanggal sa flame, and then naka-aircon yung laboratory na room. So ano mangyayari dyan? No? Ang lalamig una ay yung nasa labas ng glass, ng heavy wall na glass. And then yung nasa loob, mainit pa rin. Okay? So ang mangyayari yan, magkakaroon ng conflict. Okay? Sa behavior ng particles sa glass, and then later on, that could result to the cracking or the break of the glass. Okay? So, para maiwasan po yun siya, kaya po yung mga masyadong makakapal na type of borosilicate glass should not be heated with direct flame or hot plate. Okay? Pero kung hindi naman siya makapal, pwede na siya gamitin or gamitan with direct flame or hot plate. And third one, the third precaution, you need to avoid heating beyond its strain point. So, what do we mean when we say strain point? When we say strain point po, it is defined as the temperature at which a certain glass viscosity is reached. In other words, para mas madaling maintindihan, kapag sinabi po nating strain point, it is the point at which all movement of the glass molecules has reached a point where no more strain can be introduced to the hot glass. Kasi po, kapag nilampasan mo yung strain point, siguradong masisira na yung glass. Either mag-break siya, mag-crack siya, or mag-melt siya. Okay? Okay? So, we need to consider the strain point of the borosilicate glass that we are using. Okay? So, also another reason why we need to consider the strain point, again, because if you exceed that one, and then later on, papalamigin mo yung glass, pag papainitin mo yan ulit, no? For sure, again, magka-crack yan siya. Okay? Okay. So what are the popular commercial brands for your borosilicate glass? Actually, you're very familiar with the first commercial brand. Okay? Si Pyrex po. So si Pyrex is actually an example of a borosilicate glass. Okay? According to the book of Henry, the strain point of Pyrex is 515 degrees Celsius. In other words, no, pwede niyong gamitin yung mga Pyrex na plato, pang microwave, pang luto, pang prito, as long as hindi siya lalampas ng 515 degrees Celsius. No, yung temperature na may expose siya. Another popular brand under borosilicate glass is your Kimax. So this one, according to this website, the strain point of this one, this brand of borosilicate glass is 513 degrees Celsius. Okay. The second type or category of glass is your high silica glass. So your high silica glass in the laboratory, no, in the clinical chemistry laboratory, can be fused to quartz, no, and it can be used now later on, no, as part of your cuvette. Okay, I hope you're familiar with cuvettes. This should be, or you should have encountered this one back in PMLS 1 pa, no, in your clinical chemistry na topic in PMLS 1. Remember the parts of the spectrophotometer? Okay, so if you don't remember them, for sure you're going to remember them because that is the next week's lesson, okay, or the next topic after this one. So remember your cuvette, the purpose of that one is to hold the sample in your spectrophotometer. Okay? So your high silica glass can be found in your cuvettes. Can be found in your cuvettes. The third one is your alumina silicate glass. This one is also known as your aluminosilicate glass. So it is called as aluminosilicate or alumina silicate is because it contains silica, same with your borosilicate, contains silica, as well as aluminum oxide. Okay, so this one, the characteristic of this one is that it is strengthened chemically rather than thermally. So that is why it has greater chemical durability. And also compared to your borosilicate, your aluminosilicates are more difficult to fabricate. Okay? So, saan po natin pwede makita yung mga alumina silicate na glass? Okay? First things first, pwede po natin siya makita. Unahin na lang muna natin itong calibrated centrifuge tubes. No? So, pwede natin siya makita dito. Another one, pwede din natin makita yung alumina silicate glass sa ating tinatawag na resistors. So, ano po itong resistors? I hope na-encounter nyo ito sa physics. No? When we talk about resistors, diba, they are the ones that can reduce current flow, no? They can adjust the voltage, no? It allows us to divide the voltage. Ayan yung purpose ng resistors. Or they can actually terminate transmission lines. No? So those are your resistors. And as a matter of fact, your resistors contain alumina silicate glass. So how come or how do we do that? No, your aluminum silicate glass, you're just going to coat it with an electrically conductive film. Okay, and then you can now use it as a resistor. Okay, so sir, bakit po pwede siya maging resistor? Kasi remember, glass is not a conductor. No? So it can really impede current flow. Okay, so yun po siya. Now, the most popular commercial brand for your alumina silicate glass is called Corex. So the characteristic of Corex actually, according to Henry, it is radiation resistant. It is 6 times stronger than your borosilicate and it can resist clouding. So ibig sabihin, yung glass na ito, hindi siya madaling, kung sa colloquial term pa, hindi siya madaling blur, hindi madaling mawala yung kanyang clarity, so it can resist clouding and it can also resist scratching. Okay, in terms of use, it can be used in high precision analytical work, and in optical reflectors and mirrors. Kaya di ba napapansin niyo yung mga salamin, hindi siya madaling ma-scratch. Okay? So, ano yan siya? Aluminosilicate glass. No? Most probably Corex ang brand. Okay? So, ano lang po, precaution lang. It should not be used as a general type of glassware in the laboratory. Okay? Kasi hindi siya pwedeng gamitin sa kahit or hindi siya pwedeng incorporate lang sa kahit anong laboratory instrument. No? Kasi bakit? Mas expensive. Okay? Also, ito, additional information lang din po, your aluminosilicate glass is also seen in your iPhones. No? This one is actually an advertisement of Apple. No? So, di-enumerate nila ano yung laman ng phone. So, number 1 dyan yung aluminosilicate sheet glass. Diba? So, pwede natin makita yung aluminosilicate glass dito sa iPhones. Fourth category of glass is your acid-resistant and alkali-resistant glass. So this one is boron-free. And ito na yung sinasabi ko kaninang soft glass. Okay? So that is actually the difference now when we say hard glass and soft glass. No? Kung si hard glass, borosilicate ang synonym nun. No? Ang presence sa borosilicate, anong presence sa borosilicate? Boron. For the soft glass, okay, this stands for, or this is synonymous to your acid-resistant and alkali-resistant glass. No? Tinawag siyang soft glass kasi walang boron. Okay? So yun lang po yung difference nilang dalawa. Okay? But again, hindi ka pwede mag-classify ng glasses as hard or soft glass. Kaya in-emphasize ko ngayon, pag sinabing hard glass, kay borosilicate lang yan siya. Kay soft glass naman, kay acid-resistant and alkali-resistant na glass. Okay? So, this one, the characteristic of this one, it is actually, in terms of thermal resistance, the thermal resistance of this one is actually less than that of the hard glass, your borosilicate glass. That is why this type of glass must be heated and cooled very carefully. Okay? Okay. Now, for the popular commercial brand for this type of glass, you have your Vicor. No? So, this type of glass is made up of fused silica. It is also heat resistant and chemically inert. Again, when we say inert, it is a substance that is not chemically reactive. Okay? So, other characteristics, it is stable to all acids except for your hydrofluoric acid. Why? Because your hydrofluorics kasi, it attacks or corrodes glasses with silica. So, perhaps, maisip nyo na, hala, may silica man din yung other categories of glasses kanina. So, it is safe, It is safe to assume, class, na meron din po talagang effect si hydrofluoric acid dun sa mga previously discussed na categories of glass. Okay? But this one, in-emphasize natin. Okay? In-emphasize natin. Kasi ito siya, medyo mataas-taas rin yung percentage ng silica niya. Okay? Same with your borosilicate, diba 80%. Okay? So, most probably, sila borosilicate, aluminosilicate, same with this type of glass, mako-corrode din ni hydrofluoric acid. Okay? So, there is unlikely contamination by contact with solutions. So it's a additional characteristic for Vicor. It is relatively inert to acids and neutral salts. Sinabi na natin yan dito, chemically inert. And then chlorine and acid gases does not affect it at any temperature. So these unique characteristics of your Vicor, ito siya hindi masyado unique, itong first. Okay, kasi because of the explanation that I gave you a while ago. So these characteristics, you can actually read more about them in this article. Okay? So, it can also withstand high temperatures, up until 1,200 degrees Celsius. And then the moment that when you reach 1,500 degrees Celsius, no, it starts to soften up. In other words, it starts to melt. Okay? And then good thing about this one, no, it can actually withstand down shocks. No? If, for example, from 1,200 degrees Celsius, you're going to expose it to 0 degrees Celsius, so it can withstand that one. Okay, so that's good thing also about Vicor. So you can use this in ashing and ignition techniques. Okay. The fifth type of glass is your low actinic glass. So this one contains materials that usually impart an amber to red color to the glass. And because the glass now has a color, remember, no, light cannot easily pass through. That's why in this type of glass, no, it is good if you're going to use it to protect light-sensitive substances or materials. So what are examples of those light-sensitive substances or materials that I'm referring to? So examples of those are your bilirubin and vitamin A. So I hope you still remember, no, na, diba when we discussed the metabolism of hemoglobin in your biochemistry, diba, one of the products of metabolism of hemoglobin is bilirubin. And I hope it was emphasized by your instructor during that time, no, that bilirubin is light sensitive. Okay, so for example, if you want to test bilirubin in a blood sample of a patient, in the serum sample to be specific, no, in the serum sample of a patient, no, make sure na that serum sample is protected from light. And one way to protect it from light is to place it in a low actinic glass. Okay. Another light sensitive substance again is your vitamin A. Okay. So aside from protecting the light sensitive substances, now it can also be used to store control materials. I hope you're still familiar what a control material is. No? From what I know, no, you have already talked about control materials in your analytical chemistry, in your laboratory management, and even no, we also brought this one up in medical technology laws, no, medtech laws. Pero sa medtech laws, pahapyaw lang kasi yan siya. So more on sa analytical chem siya and sa lab management na discuss. So, no, control materials. And actually, before ako mag-proceed, no, mas i-discuss din natin si control materials when we arrive to the topic quality assurance, no, sa midterms ng clinical chemistry 1 na lecture. Okay? Kasi ako mag-discuss nun. So, review na lang muna. So, di ba yung control materials, it is actually a material that supposedly should be similar to that of a human specimen or human sample. Correct? Okay. So, in clinical chemistry, remember, the specimen that we usually use or utilize from the body of a patient is blood. Correct? Or the serum or the plasma. And remember, suspended in the serum or plasma is the different chemical substances, and one of those is bilirubin. In other words, if bilirubin is part of the sample of a human patient, that also means that in the control material, that should also be present. Correct? Okay, so that is why we also use low actinic glass when we store control materials. Okay, because it is expected that the control material is similar to the contents of the human sample that we are considering in a specific test. Okay? Okay. The sixth type of glass is the soda lime glass. And actually, this is the last type of glass. The last category of glass that I'm going to elaborate. So this one is also known as your flint glass. It is made up of silicon oxide plus soda and lime. Soda, that is actually sodium oxide, and then lime, the calcium oxide. So this one is the most inexpensive glass out of all the categories of glass. No? And it is readily made into a variety of types of glassware. Okay, so why do you think it can be readily made into a variety of types of glassware? The reason for that one is because your soda lime glass has a high thermal expansion coefficient. In other words, no, it is easy to melt. Okay, but even though it is easy to melt, no, it has also a high degree of thermal resistance. Okay, so meron din siyang high degree of thermal resistance. So easy to melt. Okay, now the problem with this type of glass, or the problem with this category of glass, is that minerals, no, can be leached from the glass into the stored solutions. Okay, and then you can expect to see this type of glass in your volumetric flask, no, in your steering rods, and even your single-use pipettes or test tubes. But again, itong mga volumetric flask, steering rods, hindi po ibig sabihin na they are purely soda lime glass. Okay? So, malaki po yung chance na may mga other components pa yan sila. Okay? So, ang point lang po natin dito is dapat alam natin yung characteristic ng each category of glass. Okay? So, what I'm going to do now, next part is about measuring vessels. Okay? Para hindi po masyadong mataas ang video na ito, no? Kasi para hindi siya, or rather para pwede siyang maputol, no? Ang gagawin natin, I'm going to cut this video, okay? And then I'm going to make another video which will focus on the measuring vessels. So the next video that I am going to post under the same module, Glasswares and Plasticwares, will still be under the same week. Okay? So, ibig sabihin, magiging part pa rin yung next video, magiging part pa rin siya ng coverage ng first quiz. Okay? So, you may now decide if you're going to continue with the next video agad-agad, or you can rest muna. Pause for a while, take a break. Okay? Sige.